Okay, so a couple of questions on significant figures I wanted to go through. In the Chapter 1 homework intro, number 83, the first set of questions here, A through D, they're all looking at multiplication and division. And so if your operation is just to multiply or divide, you want to always follow your least number of significant figures, SF. So for A, it had 9.15 divided by 4.970. So the 9.15 has 3 sig figs. Nothing's a 0 there, so there's nothing to worry about. With the 4.970, we know the 4, 9, and 7 are significant. The 0 in this case is significant because it's after the last non-zero digit and there is a decimal present. So that's telling us that that is a measured digit. So that is part of the measurement. That will be 4 sig figs. It's not a magnitude 0. It's there for the measurement. Now the rule is least always wins. So we're going to go with the 3 significant figures, right? Your answers should not be more precise than your least precise measurements. That makes sense. So for my answer, 1, 2, and 3 sig figs. And then what I'm cutting off here is 4 or less, right? I just look at that very first digit after what I'm cutting off, right? In this case, the 1. So because that's less than 4, the previous digit stays as is. So my answer would just be 1.84. For the next exercise, we're taking 1.54, which has 3 significant figures, and multiplying it by 0.03060, which has 1, 2, 3, 4 significant figures. The zeros that are in front of the 3, zeros that are in front of the first non-zero digit, those are always just placeholders. Remember, there's nothing there to measure yet. It's just a 0. There's nothing there. The 3 is the first measured digit. So in 0.03060, the 0.0, those are just placeholders. And then the 3 in the hundredths place, 0, 6, and 0. After that, those would all be significant. So 4 significant figures. And then we're multiplying that by 0.69, which only has 2 significant figures. So the answer on the calculator I get is 0.032515556, and we're going to go with only 2 significant figures because that was our least precise measurement, the 0.69. Again, here you want to remember that the zeros in front, we need them for placeholders, right, for magnitude only. So I'm going to keep them, but they're not sig figs. So in 0.03, that 3 is the first significant digit. The digit after that is a 2. I want to keep that. That's where I'm going to cut because there's my 2 significant figures. What I'm cutting off is 5 or greater, so the previous digit needs to round up. So this answer would be 0.033 to 2 significant figures. The next exercise, we've got 27.5, which is 3 sig figs, multiplied by 1.82, which is also 3 sig figs, and divided by 100.04, which is 5 sig figs. And the rule is with zeros between non-zeros, those are always significant. That made sense to me. If I can measure the 1 and the 4, I can measure the zeros between. So for my answer, again, I'm going to go with least always, right? So 3 significant figures for my answer. And I've got 0.500. Then I'm going to stop there. What follows the second 0 is a 2. And because that's 4 or less, the previous digit stays a 0. So my answer would round to 0.500. If you wanted to put that into scientific notation, you certainly could, but I don't think you have to. And then the last exercise here with multiplication and division, we've got 2.290 times 10 to the 6. Remember, if your value is in scientific notation, the sig figs are easy. Just whatever's in front of that scientific, or in front of your exponent, those are your sig figs. So 2.290, we have 4 sig figs. And we're dividing that by 6.7 times 10 to the 4th, which is only 2 sig figs. So 2.290 times 10 to the 6 divided by 6.7 times 10 to the 4. We're going to go with only 2 sig figs for our answer. So 34.1, right? We're going to cut off that 0.1, which means this would just round to 34 for the final answer. So that's what we do when multiplying or dividing. Now for number 85, we're going to switch and now look at addition and subtraction. And when you are adding or subtracting, you always still go with least, but in this case, we're going to go with decimal places, DP. So in other words, how far past the decimal was I able to measure with certainty in all of my measurements, right? So in exercise A, we've got 43.7, which is only one decimal place, minus 2.341, which has 3 places past the decimal. So my answer can only go 1 place past the decimal, to the 10th place, because of that first measurement of 43.7. So the calculator gives me 41.359, but I'm going to take 41.3, cut off that 59. Since what I'm cutting off is a 5, that means the previous digit, the 3, needs to round up to a 4. So I would round this to 41.4 for my answer. Exercise B, we've got 17.6, only 1 decimal place, added to 2.838, which is 3 decimal places, added to 2.3, only 1 decimal place, added to 110.77, which is 2 decimal places. Again, least always wins, so we want 1 decimal place for the answer. So 133.508 would just round to 133.5. Right? So in both exercise A and B here, we did not look at how many sig figs, we just look at decimal places. For exercise C, 19.6, 1 decimal place, added to 58.33, 2 decimal places, minus 4.974, which has 3 decimal places. So my answer here has to only go to 1 decimal place, right? So this is a little bit harder, 72.956. If we cut off after the 9, 72.9, what we're cutting off is 5 or greater, so the previous digit has to round up. And the way I think about it, the 9 rounds up to a 10, right? So 72.9 would round to 73.0. All right, and the last one here, we've got 5.99, 2 decimal places, minus 5.572, which is 3 decimal places. And that means our answer can only have 2 decimal places, least always wins. So the answer that I got from the calculator is 0.418. I'm going to cut off that 8 and round this up to 0.42, keeping only 2 decimal places. All right, so in exercise 83, we were just looking at multiplication division, so we just looked at sig figs. The rule is here, keep all your digits in the calculator and round it at the end. For exercise 85, we were just doing addition and subtraction. So same thing, I just kept all my digits in the calculator and then at the end looked at my decimal places. For 87 though, now we're going to combine the 2 orders of operations. And so you'll notice for exercise A, we have in parentheses, right, 24.6681, and then multiply that by 2.38. And so I'm going to go ahead and look at my rule for this parentheses first. Since I'm multiplying, I go with significant figures. My first measurement of 24.6681 obviously has 6 sig figs. The 2.38 only has 3 sig figs. So my answer that I get from this first calculation, I have to go with only 3 sig figs. So the calculator gave me 58.71. I'm going to round that to 58.7. So there's my 3 sig figs. Then I'm going to add that to 332.58. And so now I'm switching my operation type. So now I'm going to take and actually rewrite it in the calculator, 58.7, added to 332.58. And now what I look at are decimal places. The 58.7, only 1 decimal place. So my answer is going to have to round to only 1 decimal place. So 391.28 would round up to 391.3. All right, so that was the first exercise here. For exercise B, in the parentheses, this time we've got subtraction. We have 85.3 minus 21.489, and we're going to look at only having 1 decimal place for the answer because of the 85.3. So my answer would round here to 63.8, and then I'm going to divide that by 0.0059. So again, I'm going to rewrite it in the calculator, not keep all my digits from before. I'm going to rewrite it as 63.8 and then divide that by 0.0059. Now for my answer, I get 10,813.559, but obviously that's way too precise. when I look at my measurements, I took 63.8, which is 3 sig figs, divided it by 0.0059, which is only 2 sig figs. So my answer will only have 2 significant figures. So scientific notation really is best here. We're going to have the 1 and the 0 cutting off the 8, and so the 0 will round up to a 1. So you certainly could do this as 11,000 and just keep those zeros there for magnitude, don't put a decimal on it, but really probably proper scientific notation would be better. We're moving the decimal 1, 2, 3, 4 spots to the left, so it's a positive 4 on the exponent, so 1.1 times 10 to the 4. All right, and then for the next exercise, we have 512 divided by 986.7. Since we're doing division, right, we want to keep our significant figures. All right, and so I've got 512 with only 3 sig figs, so my answer would be 0.519. Rounding up, it was 0.518, but I'm going to round up because I'm cutting off a 9. So actually I can show you that, right? So 0.518, cutting off that 9, so we're going to round that up to 0.519. And now I'm going to add that. Let me actually, type it in the calculator again, 0.519, and then added to 5.44. And now that we're doing addition, we want to follow decimal places. So 3 decimal places in the 0.519, 2 decimal places in the 5.44, so 2 decimal places will limit my answer. So on the calculator, instead of 5.959, we're going to cut off that 9 in the 3rd decimal place, meaning the 5 in front needs to round up to a 6. So my answer here would be 5.96. All right, and then the last one, I have 28.7 times 10 to the 5. I use the EE key for the exponent, so I'm gonna write that in as 28.7 EE to the 5, and then I'm going to divide that by 48.533. All right, calculator gives me 59,135. But if I look at my measurements, because I'm doing division, I want to look at sig figs. 28.7 only has 3 sig figs, and then the 48.533 is 5 sig figs. So we're going to go with 3 sig figs for the answer here. So I'm going to take the 59,100, replace the 3 and the 5 with zeros just for magnitude. So 59,100, and then I'm going to add that to 144.99. So I got to retype that in the calculator, 59,100 added to 144.99. So this one we're going to show it out because this one's a little bit harder. So 59,244.99. But if I go back to the 59,100, I only had precision to the hundreds place. So I want to do the same thing for my answer here. So we're going to actually round this to 59,200. All right, or again, scientific notation, 4.92 times 10 to the 4th. All right, so either I'm okay if you use scientific notation or not. That's, to me, I feel like that's your choice. They should convey the same information. All right, so I'm just going to type this in one more time. So we got 28.7 showing you times 10 to the 5th, and then dividing that by 48.533. 59,100, going with only 3 sig figs, so 59,100. And then if I add that to 144.99, 59,244, but we're going to only go again to that hundreds place because of our first original calculation where we only kept the 3 sig figs. So we're going to keep it to 59,000 and then 200, replacing the 4 and the 4 with zeros only. All right, let's see, that was all that I wanted to do in terms of significant digits for this particular chapter. So hopefully that helps with addition, subtraction, and multiplication and division.